Over 80 countries around the world cultivate dragon fruit, making it one of the fastest-growing tropical fruits in global markets, known for its striking color and refreshing flavor. But how does this vibrant fruit go from farms to factories? Today, we'll uncover the fascinating step-by-step process of making dragon fruit juice, from harvesting and sorting to mixing, pasteurizing, and packaging on a massive industrial scale. The story of dragon fruit juice begins in the fields where the fruit is cultivated. Dragon fruit thrives in hot, dry regions with plenty of sunlight, such as parts of Asia and South America. These climates provide the perfect conditions for the cactus-like plants to grow strong and produce large, colorful fruits. Before planting begins, the soil must be carefully prepared. Farmers enrich it with nutrients and ensure it has good drainage. Since dragon fruit plants do not tolerate standing water, the crop can be grown in two ways, either from seeds or from cuttings taken from healthy plants that are at least 1 year old. Using cuttings is often preferred because it allows for faster and more reliable growth. Once planted, the dragon fruit requires several months to reach maturity. Typically, it takes between 6 months to 1 year before the plants are ready to produce fruit. During this period, farmers must take great care of the crop, providing consistent watering, pruning, and fertilization to keep the plants healthy. Because dragon fruit plants climb as they grow, they are often supported with posts or trellises to encourage upward growth and maximize fruit production. When the fruit reaches full maturity, it is ready to be harvested. The harvest is usually done by hand using a sharp tool to cut the fruit cleanly from the plant. This must be done carefully to avoid damaging either the fruit or the plant, as both are delicate. Harvesting often takes place early in the morning or late in the afternoon when temperatures are cooler, which helps preserve the freshness of the fruit. After harvesting, the dragon fruit is placed in baskets or crates and transported to the processing facility. The speed of this transport is important. Factories aim to receive the fruit quickly so it remains fresh and suitable for juice production. Once the dragon fruit arrives at the factory, the production process begins with cleaning. Each fruit is thoroughly washed to remove any dirt, dust, or debris that may have been picked up during harvesting or transport. This step ensures that only clean fruit enters the production line. After washing, the fruits are sorted. Sorting is a crucial step, as it ensures that only the best fruits are used for juice production. Workers or machines evaluate the dragon fruits based on their size, ripeness, and quality. Any fruit that is underripe, overripe, or damaged is set aside, while the high-quality ones continue on to the next stage. The sorted dragon fruits are then cut open. Their bright pink skin is removed to reveal the soft white or red flesh filled with tiny black seeds. The flesh is chopped into smaller pieces and sent to a machine that grinds it into a smooth pulp. This pulp forms the base of dragon fruit juice. The pulp is collected and transferred into a holding tank, where it is stored temporarily before moving to the mixing stage. Holding tanks are designed to keep the pulp fresh, with controlled temperature and hygienic conditions. At this stage, sugar is added to the pulp in precise amounts. The quantity of sugar must be carefully measured to create the perfect flavor balance. Sweet enough to be enjoyable, but not overpowering. Juice is cooled down again to the appropriate temperature. The packaging process is just as important as the earlier stages of production. The freshly pasteurized juice is pumped into bottles, cartons, or other containers on the factory's packaging line. Machines fill each container with the correct amount of juice, seal it tightly, and apply labels. Labels not only display the brand name, but also provide important information such as ingredients, nutritional facts, and expiration dates. Once sealed and labeled, to ensure the juice is safe for consumption and has a longer shelf life, it undergoes pasteurization. Pasteurization is the process of heating the juice to a controlled temperature for a set period of time in order to kill any harmful bacteria or microorganisms that may be present. This step is essential in modern juice production because it guarantees both safety and quality without compromising the taste or nutritional value of the juice. After pasteurization, the juice is cooled once more and is now ready to be packaged. This factory can produce thousands of yogurt bottles and spouted pouches every hour. The process is fast, clean, and fully automated. After the yogurt is made and cooled, it flows through stainless steel pipes directly to high-speed filling machines. With perfect precision, each bottle is quickly filled with smooth, creamy yogurt and then tightly sealed to keep it fresh. The sealed bottles move along a conveyor belt where they are labeled and packed into boxes. At the same time, spouted pouches are also filled and sealed using advanced machines designed for soft packaging. Robots and automatic arms carefully stack and organize the boxes and pouches for shipping. Every step is performed at high speed, but with great accuracy, ensuring no product is wasted. This modern technology allows the factory to deliver fresh, high-quality yogurt efficiently to stores around the world. As we continue our journey into food production, let's explore how cow sausages are made in a factory. Factories use a step-by-step process to make them tasty and safe to eat. First, fresh cow meat is cleaned and ground into fine pieces. Spices, salt, and other flavorings are mixed into the meat to give the sausages their delicious taste. The seasoned meat is then stuffed into casings, which are thin tubes made from natural or synthetic materials. These casings hold the meat together and give the sausages their classic shape. Once stuffed, the sausages are linked into portions and cooked in ovens or smokehouses to enhance their flavor and ensure they are fully cooked. After cooking, the sausages are cooled and inspected for quality. They are then packaged in plastic wraps or vacuum-sealed bags to keep them fresh. Finally, the sausages are boxed and sent to stores, ready to be enjoyed in meals or on the grill. Eggs are a versatile ingredient used in various industries, from bakeries and pastry shops to pasta factories. Need to separate egg whites from yolks. This machine can accomplish this at a speed of 220 eggs per hour. For sorting eggs, the MT8 machine excels with 12 brushes and the ability to adjust the ideal temperature between 40 degrees Celsius and 55 degrees Celsius. This machine designed to wash, sort, and separate egg whites from yolks with remarkable efficiency, processing up to 25,600 eggs per hour. The process of making KitKat chocolate bars is a meticulous process that combines art, science, and advanced technology. It begins with the careful selection of high-quality ingredients, including cocoa beans, milk, sugar, and flavorings, which are rigorously tested to meet strict quality standards. The cocoa beans are roasted, ground, and mixed with milk and sugar to create a smooth chocolate paste, forming the base of KitKat's iconic taste. In the mixing and molding stage, the chocolate and wafer layers are combined using specialized machinery to achieve the perfect balance and texture. The bars are then shaped, cut, and cooled in temperature-controlled chambers to ensure consistency. After cooling, the bars are wrapped in sustainable packaging designed to preserve freshness. Quality control measures, including visual inspections and advanced tools like X-rays, ensure every KitKat bar meets exacting standards. This dedication to precision and quality has made KitKat a globally beloved chocolate treat. From cacao farms to bustling factories, chocolate manufacturing is a blend of precision and artistry. Each step in this journey, from harvesting cacao beans to creating the final chocolate bar, is guided by both intricate science and a passion for flavor. The process of making chocolate starts in tropical regions where cacao trees produce large, colorful pods. Inside each pod are cacao beans, which are harvested by hand. Farmers open the pods and scoop out the beans, which are then left to ferment for several days. This fermentation is crucial as it brings out the beans' natural flavors, setting the foundation for that signature chocolate taste. The beans are left to ferment in wooden boxes or under banana leaves. During fermentation, natural chemical changes occur, giving the beans a deeper, more complex flavor. After fermentation, the beans are dried under the sun for about a week before being packed and sent to chocolate factories. Once the dried beans reach the factory, the first step is roasting. Roasting helps to develop and enhance the flavor of the chocolate. The beans are roasted at a specific temperature and time, depending on the type of chocolate being made. For dark chocolate, beans may be roasted at a higher temperature, while milk chocolate often requires a gentler roast. During roasting, the shells of the beans become brittle, making it easier to remove them in the next step. The beans release their delicious aroma, filling the factory with the scent of chocolate. After roasting, the beans are cracked open and their outer shells are removed in a process called winnowing. This leaves behind cacao nibs, which are the purest form of chocolate. The nibs are packed with cocoa solids and cocoa butter, both essential for making chocolate. Next, the cacao nibs are ground into a thick paste known as chocolate liquor. Despite the name, chocolate liquor doesn't contain alcohol. It's a pure liquid form of chocolate, rich and intense in flavor. The chocolate liquor then undergoes a process called conching. During conching, the chocolate is continuously mixed and aerated, often for hours or even days, to develop a smooth texture and mellow flavor. Conching breaks down particles, making the chocolate creamier and less gritty. Depending on the type of chocolate, other ingredients like sugar, milk powder, and vanilla are added to the chocolate liquor. For milk, chocolate powdered milk gives it a creamy taste, while white chocolate contains no cocoa solids, only cocoa butter, sugar, and milk powder. These ingredients are carefully measured and mixed in, ensuring that every batch has the perfect balance of sweetness and texture. Once the chocolate is blended, it goes through a process called tempering. Tempering involves cooling and reheating the chocolate at specific temperatures to align the cocoa butter crystals. This step is essential for giving chocolate that shiny finish and satisfying snap. Tempering also ensures that the chocolate will have a smooth texture and won't easily melt when handled. After tempering, the liquid chocolate is poured into molds to give it shape, whether it's a bar, truffle, or unique shape. The molds then go through a cooling tunnel where the chocolate solidifies, setting the shape and giving it that glossy appearance we all recognize. Once cooled, the chocolate is ready for packaging. Automated machines wrap each piece with precision, protecting it and ensuring freshness. Packaging is not just for preservation, it's a part of the brand experience, giving each chocolate product its unique look. The production of beef patties in a factory involves careful processes and strict quality control to deliver a consistent and delicious product to consumers. The process often begins with selecting high-quality cuts of beef, usually a combination of lean and fatty meat, to achieve the desired fat content in the final product. The meat is then ground using industrial meat grinders to create a coarse mixture. After the beef is ground, it is then shaped into patties using specialized patty-forming machines, which can produce patties of uniform size and shape to ensure consistency in cooking. These machines can form hundreds of patties per minute, increasing efficiency in production. After forming, the patties may undergo a process called tempering, where they are chilled to a specific temperature to improve their shape retention and prevent them from falling apart during further processing. Once tempered, the beef patties are packaged for distribution to retail outlets or food service establishments, where they may be further processed or cooked before being served to consumers. Stringent quality control measures are in place throughout the entire production process to ensure that the beef patties meet safety standards and maintain their quality. Have you ever wondered how your favorite cookies are mass-produced in a factory? It all starts with choosing the finest ingredients. Factories use high-quality flour, sugar, butter, and other essentials in bulk. These are precisely measured using automated systems to ensure consistency in every batch. In industrial mixers, the dough is created. The mixing process is carefully controlled to ensure the perfect blend of wet and dry ingredients. Once the dough is ready, it's transferred to specialized machines designed to shape the cookies. Whether it's traditional round cookies or fun shapes, the dough is rolled, cut, or pressed into molds. The shapes then move along the conveyor belt, ready for the next step in the journey. Next comes the most crucial part: baking. The shaped dough travels into large commercial ovens, where temperatures are perfectly regulated to bake the cookies evenly. These ovens can handle thousands of cookies at once. As the cookies bake, their flavors are sealed and their textures come to life, whether crispy or chewy. It all depends on precise timing and temperature control. Once the cookies come out of the oven, they're sent to a cooling area. This helps them set, ensuring that they maintain their structure and don't crumble when packaged. Each cookie undergoes strict quality checks to make sure it's up to standard before heading to the packaging line. Now that the cookies are cool, it's time to pack them up. Advanced packaging machines quickly and efficiently wrap the cookies, ensuring they remain fresh and undamaged during transportation. And here we have a chocolate bar's factory. The process of making Reese's peanut butter cups involves combining rich chocolate and creamy peanut butter to create the iconic treat. It begins with preparing the peanut butter filling. A mixture of roasted peanuts, sugar, salt, and stabilizers is blended into a creamy but slightly gritty consistency. In the production line, specially designed molds are filled with a layer of melted chocolate to create the cup's base and edges. The molds are then cooled to harden the chocolate, forming a sturdy foundation for the filling. Finally, the Reese's peanut butter cups are removed from the molds, wrapped in distinctive packaging, and subjected to quality checks. Afterward, they are boxed. These machines cut the cheese into uniform slices, ensuring consistency in size and thickness. The slices are then arranged neatly onto conveyor belts and transferred to packaging units. Hygienic, airtight packaging is applied to maintain freshness and extend shelf life. Some factories include additional steps, like labeling or sealing the packs in bulk for shipping. This streamlined process ensures the cheese reaches consumers in perfect condition, ready for use. From a pharmacy on the streets of Atlanta to a global phenomenon, Coca-Cola has captured the world's taste buds. With an astounding 10,000 servings enjoyed every second, this iconic drink has become more than just a beverage. It's a symbol of refreshment and nostalgia. The production of Coca-Cola begins with the main ingredients include water, sweeteners like sugar or high fructose corn syrup depending on the country, caffeine, and a blend of natural flavors. The exact combination of flavors is a closely guarded secret, often referred to as Merchandise 7X. While most of the ingredients are common, the proprietary flavor mix is what sets Coca-Cola apart, giving it a unique taste that has been cherished for over a century. The process begins with purifying the water, which is the primary component of Coca-Cola. Factories use advanced filtration systems to remove any impurities, ensuring that the water meets Coca-Cola's high-quality standards. Purified water helps maintain a consistent taste, regardless of where in the world the drink is produced. After water filtration, it's time to make the syrup base. This syrup is the concentrated form of Coca-Cola that will later be mixed with carbonated water. The purified water is combined with sweeteners and the proprietary flavor blend in large stainless steel mixing tanks. Automated machines measure and mix these ingredients with precision to ensure consistency. Quality control is crucial during this stage, as even a slight variation could alter the drink's iconic flavor. The syrup base is continuously tested for taste, consistency, and quality. Once the syrup base is ready, it's time to add the fizz. Carbonation is what gives Coca-Cola its refreshing bubbles. This step involves pumping carbon dioxide gas into the syrup base under high pressure, creating the signature effervescence. The amount of carbonation is carefully regulated. Too much or too little could change the experience of drinking Coca-Cola. This is done in large carbonation tanks, ensuring that the gas mixes evenly throughout the liquid. While the syrup is being prepared, the factory also produces bottles for the beverage. Coca-Cola bottles can be made from either glass, plastic, or aluminum. Quality control is a top priority for Coca-Cola, as consistency in flavor and quality is key to the brand's reputation. Throughout the manufacturing process, samples are taken and tested to ensure they meet Coca-Cola's rigorous standards. Technicians test for taste, carbonation levels, and purity, ensuring each batch of Coca-Cola matches the brand's standard. Each bottle or can is carefully inspected for any defects before filling. Modern quality control technologies such as high-speed cameras and sensors detect any imperfections. Only bottles that meet Coca-Cola's quality standards move forward in the production line. The bottling process is a high-speed, automated operation. The carbonated Coca-Cola syrup is poured into bottles or cans, typically at a rate of thousands of units per minute. These filling machines are designed to minimize any loss of carbonation and prevent any outside contamination. Immediately after filling, each bottle is capped to lock in the carbonation and preserve freshness. The capping process is quick, often happening within seconds of filling, and seals the drink tightly. The caps are made from special materials that maintain the seal while withstanding the pressure inside the bottle. Once filled and capped, each bottle or can is labeled with Coca-Cola's iconic branding. The labels include important information such as ingredients, nutritional details, and the brand's trademark logo. This labeling process is also automated with high-speed machines, applying the labels with precision to ensure they're aligned correctly and securely attached. After labeling, the bottles are grouped into cases and packaged for distribution. In most factories, Coca-Cola products are packed in cardboard boxes, plastic wrapped, or pallets, making them ready for transport. Some factories also produce multi-packs for bulk buying, ensuring they can meet various customer needs. Once packaged, the finished products are ready for distribution. Coca-Cola uses a vast network of logistics to transport the drinks from the factory to distribution centers, and then onto retail stores. Refrigerated trucks are often used to ensure the drinks are kept at optimal temperatures during transport. In just a matter of days, a bottle of Coca-Cola can go from production to being stocked on store shelves, ready to be enjoyed by customers around the world. Next up, let's explore the production of strawberry jam in a factory. The process begins with the selection of ripe, juicy strawberries, sourced from farms and inspected to ensure they meet strict quality standards. The strawberries are thoroughly washed and sorted before being transferred to large stainless steel kettles. Sugar, pectin, and sometimes lemon juice are added to the strawberries to enhance flavor and aid in thickening. The mixture is then cooked at controlled temperatures, ensuring the natural flavors and vibrant color of the fruit are preserved. Once the jam reaches the desired consistency, it is poured into sterilized glass jars using automated filling machines. The jars are sealed immediately to lock in freshness, and then pasteurized to ensure a long shelf life. After cooling, the jars are labeled and undergo rigorous quality checks before being packed and distributed to stores ready to delight customers. Bread production begins with high-quality ingredients. Factories source the finest flour, water, salt, and yeast. Some breads may also contain oil or other seasonings depending on the variety being made. Next, the ingredients are mixed together in large industrial mixers. Water and flour are combined with yeast and salt to form a smooth dough. Once the dough reaches the perfect consistency, it's divided into individual portions. These portions are then shaped into flat discs. Factories use specialized equipment to ensure each piece of dough is the same size and thickness for uniform baking. The dough is then sent to proofing chambers where it rests and rises slightly. Bread is baked on hot conveyor belts or stone ovens. The heat causes the dough to puff up, creating the signature air pockets inside. Each one spends just a few minutes in the oven baking to a soft golden perfection. Some breads are cooked until slightly crispy depending on the desired style. And here we have the process of making burger buns. It all begins with selecting high-quality ingredients. The main components of burger buns are flour, water, yeast, sugar, and butter or oil. Once the ingredients arrive, it's time to mix the dough. Large industrial mixers combine ingredients in precise quantities. After mixing, the dough is divided into perfectly portioned pieces. These pieces are shaped into buns using automated machines. At this stage, the buns may also receive a dusting of flour or sesame seeds, depending on the type of burger bun being made. Once shaped, they are sent to the proofing chamber. This is a warm, humid environment where the dough rises for the final time before baking. Next up is the baking process. The buns bake at high temperatures until they turn golden brown. This step requires precise timing and temperature control to ensure that they are perfectly baked. During baking, the yeast creates bubbles in the dough, giving them their signature soft texture. After baking, the buns need to cool down before they can be packaged. They are transferred to cooling racks where fans help bring them to room temperature. Once cooled, they are ready for packaging. In the packaging section, buns are placed into plastic bags or other packaging materials to keep them fresh. Automated packaging machines ensure the process is fast and efficient. Over 60 billion coffee capsules are used around the world every year. That's nearly 2,000 every second. Behind these tiny pods lies a complex, high-speed process that blends precision engineering, fresh coffee beans, and modern technology. Today, we take you behind the scenes to see how these capsules are made in the factory, from roasting and grinding to filling and sealing. The journey of a coffee capsule begins on coffee farms in tropical countries such as Brazil, Colombia, Ethiopia, and Vietnam. These regions provide ideal growing conditions: warm temperatures, regular rainfall, rich soil, and high altitudes. Coffee grows as small cherries. Inside each cherry are 2 beans. These cherries take months to ripen, and once they turn red or purple, they're ready for harvest. On many farms, cherries are picked by hand to select only the ripest ones. Larger farms may use machines to speed up the process. After harvesting, the cherries go through a processing step to remove the beans. This can be done by drying the cherries or washing and pulping them. Each method gives the coffee a different flavor. Next, the beans are dried until they reach the right moisture level. Once dry, they go through hulling to remove the outer layers and are then sorted by size and quality. Broken or defective beans are removed to ensure only the best are used. Finally, the beans are packed into large sacks and shipped to coffee factories around the world. When the beans arrive at the factory, the first step is to check their quality. Workers or machines inspect the beans to make sure they are clean and not broken or moldy. Factories use special tools to test the moisture content of the beans. If the beans are too wet or too dry, they won't roast properly. Sometimes, beans from different farms are mixed together to create a special blend. This helps companies make a consistent flavor that customers recognize and love. Next, the beans go through the roasting process. Roasting is what gives coffee its dark color, strong smell, and delicious taste. The beans are placed into large roasting machines that heat them to high temperatures, usually between 180 degrees Celsius and 240 degrees Celsius. The roasting time can range from 10 to 15 minutes, depending on the type of roast the company wants to produce: light, medium, or dark. Lighter roasts are more acidic and have a fruitier flavor. Darker roasts are stronger and more bitter. Once roasted, they are cooled quickly to stop the cooking process. Cooling is done by blowing cold air or spraying water. After roasting, The beans are ground into small particles. Grinding is a very important step. If the grind is too fine or too coarse, the coffee might taste bad or brew incorrectly in the capsule machine. Factories use large grinders that can handle hundreds of kilograms of beans per hour. The size of the grind is chosen based on the type of capsule being made. Now that the coffee is ground, it is moved to the capsule filling area. Here, machines measure the exact amount of coffee needed for one capsule. Most capsules contain between 5 to 7 grams of ground coffee. This may not seem like much, but it needs to be very precise. Even a small difference in weight can change the taste of the coffee. While the coffee is being ground and measured, other machines are preparing the actual capsules. They are usually made from plastic, aluminum, or biodegradable materials. Plastic and aluminum capsules are made using molds and heat. The material is shaped into small cup-like containers that are strong enough to hold the coffee and survive the brewing process. Some companies use eco-friendly materials like compostable plant fiber to reduce waste. Each capsule is carefully checked to make sure it doesn't have cracks or defects. A broken capsule could leak or not work in the machine. Once the ground coffee is ready and the empty capsules are made, the filling and sealing process begins. The ground coffee is filled into the capsule and then sealed with a lid. The lid is usually made of foil or a similar material. Sealing is done with heat and pressure to make sure no air gets inside. This is important because coffee loses its flavor when exposed to oxygen. Some factories even flush the capsules with nitrogen gas before sealing. This helps keep the coffee fresh for longer. The sealed capsules are then checked by sensors or cameras to ensure the seal is tight and there are no leaks. Before the capsules are shipped out to stores, the factory does final quality checks. Workers open random packages to test the coffee. They brew the capsules using machines and taste the coffee to make sure it meets the company's standards. They also test the capsule's durability, sealing strength, and freshness. If any problem is found, the batch may be stopped and reviewed. Once the capsules pass all quality tests, they are ready to be sent to stores, warehouses, or cafes. In this factory, homemade-style pizzas are made for supermarkets without changing any ingredients. The goal is to keep the same taste and quality as a pizza made at home. Fresh ingredients like dough, tomato sauce, cheese, and toppings are used. The machines mix and knead the dough, just like in a home kitchen. Then, the dough is shaped into pizza bases. A layer of rich tomato sauce is spread evenly, followed by fresh cheese and a variety of toppings like pepperoni, mushrooms, and vegetables. The pizzas are baked in special ovens that give them a homemade texture and taste. Once cooled, they are carefully packed and sent to supermarkets. Customers can then buy them and bake them at home for a fresh and delicious meal. The journey of making 7-Up begins with the main ingredients: carbonated water, high fructose corn syrup, and natural lemon-lime flavors. These are carefully blended to create the base syrup. The mixture is then precisely carbonated, giving 7-Up its signature fizz. Next, the carbonated syrup is piped into a filling machine that dispenses the perfect amount of soda into each bottle or can. Every bottle and can is capped and sealed to lock in, the carbonation keeping the soda fresh and fizzy. Throughout the process, rigorous quality control tests ensure that every can meets 7-Up's high standards. Once checked, the bottles and cans are labeled and packed for distribution, ready to be shipped to stores worldwide. From factory to your fridge, that's how every can of 7-Up is made. Crisp, refreshing, and always ready to quench your thirst. 1.6 billion liters of milk are consumed worldwide every day. thanks to 260 million dairy cows. To meet this massive demand, factories use advanced machines that transform liquid milk into powder. But how is this done? And what makes powdered milk so important? The idea of turning milk into powder was first introduced in 1802 by French scientist Francois, primarily as a way to feed soldiers during wartime. Milk powder was easy to carry, didn't spoil, and could be used as a nutritious food source. Today, the United States produces more than 79 billion liters of milk each year, which averages to 87 liters of milk per person per year. This milk comes from over 60,000 dairy farms, supported by around 9 million cows, bred specifically for milk production. Modern dairy farms have adopted advanced technologies to improve efficiency. A single farmer can hand milk about 6 cows per hour, but with the help of milking machines, up to 100 cows can be milked in the same amount of time. This technological improvement not only makes the milking process faster, but also enhances the quality of milk. On larger farms, cows are milked in rotary carousels or milking parlors, where up to 80 cows can be milked at once. The milking machine uses a cup that adapts to the cow's udder, mimicking the effect of a human hand by applying a gentle suction and massage. This action encourages the cow to release milk. As the milk is collected in a container, a vacuum pump helps transfer it through a hose and into a storage tank. The milk is carefully analyzed during the process to ensure it is of high quality. For example, if the milk is too hot or contains blood, it is discarded automatically. After the milk is collected and passed quality checks, it is stored in refrigerated tanks at a temperature of 3 degrees Celsius to keep it fresh. The milk is then transported from the farm to the processing plant in refrigerated trucks. Once it arrives, the milk undergoes further inspection in a laboratory, where its fat and salt content are checked to ensure they meet required standards. If the milk is accepted, it is pumped into large storage tanks that can hold millions of liters. However, the milk still contains too much fat for most people's diets, so the next step is to separate it. Raw milk contains various solids, such as fat, proteins, and minerals, all suspended in liquid. To separate these solids, the milk is sent through a centrifuge, a machine that spins the milk rapidly to separate the lighter milk from the heavier solids. The heavier skimmed milk moves toward the outside, while the cream collects in the center. This process allows for the production of skimmed milk, which is then used to make powdered milk. Even after separation, the milk still needs to be pasteurized to remove harmful bacteria and ensure it is safe for consumption. Pasteurization involves heating the milk to about 72 degrees Celsius for a set period, killing harmful bacteria without changing the milk's taste or nutritional content. After pasteurization, the milk is cooled quickly to maintain its quality. This process takes less than 40 seconds and kills up to 99% of bacteria present in the milk. The next step is concentration, where the water content is reduced and the milk solids become more concentrated. This is done by introducing the milk into an evaporator, a device designed to remove water by turning it into steam. The evaporator works by using heat to turn the water in the milk into steam, which is then separated. The milk is pumped through several towers, where it is heated and concentrated. This process is repeated multiple times until most of the water has been removed. The remaining concentrated milk is then cooled, packaged, and stored in tanks. Once the milk has been concentrated, it is ready to be made into powder. The concentrated milk is cooled to prevent moisture from forming and causing clumping. It is then packaged into airtight containers, such as sealed cans, to protect it from moisture and contamination. This packaging is crucial for ensuring the powder remains fresh and easy to store. The entire process of turning fresh milk into powder is an intricate and carefully controlled operation, but it is essential to ensure the milk remains safe, fresh, and ready for consumption. The production of powdered milk is an important part of the dairy industry. With the use of advanced technology and rigorous quality control processes, factories can efficiently turn fresh milk into a stable, long-lasting product. This process allows milk to be transported easily, stored without refrigeration, and enjoyed by people around the world.